Hello everyone, welcome to the session. In this session, we are going to discuss about Euclidean distance. First, what is Euclidean distance? Euclidean distance is defined as the distance between 2 points or vectors. This is used in NLP natural language processing to find the distance between vectors. In NLP, text represented as vector using word embedding techniques and Euclidean distance can be calculated between the vectors. This calculated distance is used for finding the similarity among documents. Less the value of distance, more the similarity between the documents. If Euclidean distance is zero, it means that both objects or documents or word or paragraph are identical. Let's see the formula to calculate the Euclidean distance. Here I have attached one screenshot and this is for the two-dimensional vector. We can calculate Euclidean distance for any dimensional vector. It could be 2D, it could be three-dimensional vector, it could be four, it could be nth dimensional vector. Just for the simplicity, I am using the two-dimensional vector. Two-dimensional vector means we have two values for that particular vector, x2, xy or x1, y1. You can have multi-dimensional vector also. v1 is equal to x1, x2, x3, x4 dot xnth. In this graph, d is the Euclidean distance. So it is the length of that particular line between 2 points A and B. This is the formula to calculate the Euclidean distance between two-dimensional vectors. You can also write the formula for nth dimensional vector also in the similar way. We will also see this with the help of one example. Let's calculate Euclidean distance between documents. Let's open the board. Now let's see with the help of one example how to calculate the Euclidean distance. I have taken the two documents. First one is this is D1, how are you? And second one is D2, how are you doing? So these are the two documents. We need to find the Euclidean distance between D1 and D2. So first the simple rule is we need to convert these two in the vector form. For that, we will use the technique bag of words. So what you need to do is you need to write unique term from both these documents. So both this sentence. So the unique term are how are you. So these are the unique terms from document 1 and unique terms from document 2. How already we have written, are we already written, you already written, and doing is left. So let's write doing. These are the four terms which are unique in both the documents. Then we need to find the vectors. So for that we can write d2 and d1 like this. So first let's see the d1. So first term of d1 is how. It is present, yes. Are, yes. You, yes. Doing, no. Let's see the second document, how are you doing. First is how. So let's see if it is present in this collection. How, yes. Are, yes. You, yes. Doing, yes. So the vector representation of D1 document is 1, 1, 1, 1, 1 and 0. Right? So this is the 1, 1, 1, 0. And the further D2, the vector representation is all 4. Now we have got the vectors. We can easily calculate the Euclidean distance. So let's draw the graph. So we can consider anywhere. This is D1, this is D2, and we need to calculate this D. This is D. So which is the Euclidean distance. This is D1 and D2 is this. So now let's calculate the D. So what would be the D here? Square root of this minus this 1 minus 1 square plus second minus second 1 minus 1 plus third minus third 1 minus 1 plus fourth minus fourth 1 minus 0 square. So it would come out, how much it would come? It would come 1 minus 1 0 0 0. So this is 0 0, this is 0, this is 1, and square of 1 is 1. The value would come 1, and the square root of 1 means 1. So the Euclidean Euclid E dot D is 1 between these two documents. Means between these two documents the Euclidean distance is 1. If Euclidean distance is 0, means both the documents are similar. So this is how you can calculate the Euclidean distance for any documents or any sentence. And first you should understand this very well, how you can get the vector from the text. We will see the different techniques of getting the vectors from text in coming videos. But for now, just understand this simple technique. Here in this example, I have mentioned two documents, document 1, document 2, and this is the screenshot I have attached, which is telling the vector against these doc 1 and doc 2. So vector d1 is this, vector 2 is this. With the help of same technique which we have just discussed in last slide, and the ED Euclidean distance would come out as square root 3, which would be 1.73. If you are liking the content of the channel, please do subscribe the channel. Thanks for watching. See you in the next video.